Alright, so we're going to start on number 8 now with this one. It says, find the quotient. Anybody recall what quotient means? Answer to a remainder, or to a, whatever, division problem. Okay, so here, I would either use synthetic division or long division. Okay, which do you guys prefer? Yeah, synthetic. Okay, so do you remember what the lineup is? Good. We have to take the opposite of, like, basically set this equal to 0, and so we end up getting -2 right here. Now, what goes along the lines up top? All the coefficients. Good term there. Okay, so 1, 2, and then 2, and then 1. Okay. Now, what happened if, let's say, we didn't have this x term? Do you guys remember what you have to put? Yeah, the 0 placeholder, right? Okay. So let's go ahead and do this. So the 1 comes down. Remember, it gets a freebie. Okay, and then you just multiply. So -2 times 1 will give me -2. That's going to give me a 0. This time that is going to be 0 again, and then that's going to be 2. And this time this is -4. Okay, and then that gives me -3. All right. Now the very last position right here, this is your remainder. Okay, and then these are this is the constant term. That's the x term. That's the x squared term. So you have x squared plus 0x, and then plus 2, and then your remainder is -3, and we always divide it by x plus 2 there. X plus 2. Okay? So quotient and the remainder. Everybody got that? Okay. Now next, oh, geez, this one's going to be lovely. So let's do that. Alright, so we have to factor, divide, and then simplify. And in fact, this is nice because it's telling you what steps you need to do. Okay? So here, I'm going to factor the top using the x. So factors of -4, that would give me -3, are going to be 4 and 1, negative. And then this one, divide by your a term. This one is -2 over 1. Okay? So I have x minus 2, and then this one is 2x plus 1. That's up top. Now on the bottom, that's a difference of 2 squares pattern, so I know that that's going to be x plus 1 and x minus 1. And then here I got to multiply by the reciprocal, so that means we'll do the bottom first. So factoring the bottom using the x, we get x plus 2 and then x minus 1. Okay, so that's factoring this part right there. Now on the top, which is going to be our new bottom, I'm going to use the x. So that's going to be 4. Factors of 4, that would give me 5. It's going to be 4 and 1. Divide by your a term, which is 2. So that one's going to be x plus 2 and then 2x plus 1. Okay, that can kind of take a long time. But now this is the fun part. Now basically we're just going to cross out any factors that are the same. Okay, so x minus 2, there's none on the bottom. 2x plus 1, I see one right here and right here. Okay, what else? X plus 2 and x plus 2.
X minus 1?
Yeah, x minus 1 and x minus 1. Okay, so that's gone. All we're left with then is x minus 2 and x plus 1. Now, of course, we could divide out these x's, right? You better not, okay? Never do that, okay? Or else Mr. Wilson will be very upset. That's your answer. Okay? If you do that, then don't say that you took me as a teacher. Okay? That's going to make me look. Don't ever say, Mr. Wilson. Who'd you have? They're going to ask you, who'd you have last year? And you're going to say Wilson. And then I'm going to get made fun of in the teacher room.
No, we had someone else.
Okay.
I just can't remember that.
What's that?
Somebody goes down.
No. Well, sometimes they talk some crap. Okay. There's an adjustment here. 10 needs to be right here. That has to be a negative in order for things to kind of work out. Now, if you guys didn't do that, then don't sweat it. I mean, you're okay. You know, the world's not going to end. All right, so rewrite in factored form. Yes, sir. Got it. On the bottom, that's going to be x plus 2 and x minus 1. Now on the top, if we're going to use the x here, that's going to be factors of -8. That would give me -7. That's going to be -8 and 1. Divide by my a term. Okay, so that's going to be x minus 4, and that's going to be 2x plus 1. Okay, don't touch it. Wait. Okay. First, what we want to do is figure out what's going to make the denominator equal to 0. What are my bad points? What can't x equal here? Good, x can't equal -2 and +1. Okay? Now, if any of these divide out, that becomes a whole. You understand that? Okay? Do any of them divide out? No. Okay, so then what are these then? Because we already did this. What are these 2 points then? Good, they're our vertical asymptotes. So here, I could just take this guy and just basically move this whole party downwards. Okay? This one goes right there for vertical asymptotes. Okay? Now, are there any holes? Yeah, so we'd say none. Okay, now let's go ahead and look at what's going on here. Horizontal asymptotes. I have it written down on the board, but horizontal asymptotes basically work like this. Okay? If the bottom is bigger, big bottom, you got to zero in on it, right? So that's going to be y equals 0. Okay, so if the bottom exponent is bigger, then your horizontal asymptote is going to be 0. Okay, now if they're the same, like in this case, then it's going to be the fraction of the leading term. So here, the horizontal asymptote is going to be y equals 2 over 1. Does that make sense? Now, what happens if the top is bigger? Okay, if the top is bigger, then that means you have to divide it. And if in that previous problem where we did the dividing, where you take the little guy and divide it into the big guy, we use synthetic division. We got a quotient and we got a remainder. Okay? Watch, check this out. Oh, no, that's not the same thing. What's that? No, it's 2 over 1. That's a division bar. So 2 over 1, that's how I got it.
So you can't just put it as 2?
You can put it as 2 if you want. Here, watch, I'll make you happy. Like that.
There you go, Wagner.
Okay. So you divide it and then the quotient without the remainder. Okay? The quotient without the remainder, that's going to be your or your slant asymptote, okay? All right. Now, x-intercepts. We did this. We got this and we got this. Now last thing. X-intercepts are kind of easy. All you're going to do is just see what up at the top, what are the solutions for the numerator? Okay, so what would be the solution right here for this x minus 4? Good, so x equals 4. What's going to be the solution up here?
1.
Good. That's that. Okay? Alright, that was an easy one. Let's scroll down and do some more. Okay, number 11. It says find the zeros. Another way of saying zeros is saying find the solutions. Okay? Here we have something that's raised to the third power. So what you're going to have to do is do the p over the q. You guys recall that? Okay, so p over q works like this, where you take the 2 and the 3, and then you take all the factors of the numerator, which is 1 and 2, and all the factors of the denominator, which is 1 and 3. Okay, then you do all the combinations. So 1 over 1 is going to be one solution. 1 over 1 is 1, and then 1 over 3, that's the other one. Okay, so basically I just said this guy and this guy. Okay, then I have to go 2 over 1, and then 2 over 3. Okay, so basically I just want this one with this one. Okay, and then don't forget plus or minus for all of them. So these are all of our possible zeros. Okay, unfortunately there's no real easier way to do this. You have to go through this motion, but at least you don't have this range anymore, right? From negative infinity to positive infinity. You narrowed it down to like maybe 5 or 10, okay? So here, what do you guys want to start off with?
Negative.
Okay, let's try -2 if you want. Okay, so I'm going to put the 3, the 4, the -1, and the -2. 3 gets a 3b. That's going to be -6. That'll be -2. That'll be +4. That's not going to work though. Okay, so -2 doesn't work. Let's try another one. How about +1? +1. So 3 comes down. That's going to be 3. Now let's do -1. -1, that'll be -3. That'll be a +1. That'll be a -1. That'll be negative 2. That becomes a positive 2, and that gives us a 0. All right, so that means that one of the solutions already I know is going to be x equals negative 1. You guys see that? Okay, then there is no remainder, so the rest of it looks like this. 3x squared plus x minus 2. So in factored form, this is what this sucker looks like. Okay? So how can we finish up this? What are the solutions here? Are there factors of negative 6 that would give me 1? Three and 2, 1's negative, and then divide by your a term here. Okay? So now we just take the opposite. Okay? What's the opposite of 1?
Negative.
Negative 1. Okay? What's the opposite of negative 2/3?
Positive 2/3.
Okay. Do you have to write this twice? No. But am I going to erase it? No.
No.
Okay? All right. Let's graph this. What's this going to look like when I graph it?
Parabola.
How do you know? Because it's something that's squared. So that's how I know that this is going to end up being a parabola. Now, is it going to be a happy face parabola or a sad face parabola?
Happy face.
How do you know?
Because positive.
What's positive? The 2? The a term, okay? If this is positive, so that means that it's going to be a going up parabola. Now that's going to help you on a multiple choice test, okay? You can eliminate a lot of your choices that way. Does anybody know what form this is in?
Slope.
No, it's in vertex. That's linear equations.
That's the easy one.
Yeah. So we could figure out the vertex really simple here. You just take the opposite, and that's going to be negative 4. And so now when I go to graph this, all I'm going to do is go down to negative 2, and then 1, 2, 3, 4, put a dot. That's where my vertex is. I know it's going to be a happy face, and then there's something else that I can put right here. What is this thing? Good, axis of symmetry. Okay, axis of symmetry means whatever you put on this side, it's going to look the same on this side. Okay, that's the axis of symmetry. So all I'm going to do is I'm going to pick a real simple point all the way down here. Why don't we use a t-chart for 273 and 1/3? Okay, so I'll substitute that in, and let's see what we get. Okay, now I'm obviously not going to use this. What would be a better choice? 1 would be fine. How about something that's easier? 0. Okay, so if I substitute 0 in here, let's see where it is on this y-axis. So 0 plus 2 is going to be 2. 2 squared is 4. 4 times 3 is 12. What's 12 minus 4? 8. So that means at 0, 8, we have a point. Okay, so I know that my parabola is going to go like that. Okay, and then I could just reflect the point 2 units over, up at 8, right here. Whoa, excuse the curve there. Here, well, hold on, let's start here. Just go up. Sometimes you just have to. Okay, so there's your parabola. Make sense? Of course it does. Okay, left and right behavior. So here, this is the recapper one where you guys have to remember that if you had x, it's going to be a line like this. Okay, if you had negative x, what is it going to look like? A line, but it's going to be going down, right? Okay, now what happens if you have x squared? What is it?
2 lines.
It's a parabola. No, it's a parabola. Okay, what is a negative x squared? That's an upside down parabola. Okay, and then let's do x to the 3rd. What does that look like? It's a disco that looks like this, right? Okay, now what about negative x cubed? It's going like this, right? Going down. Okay, so what is x to the 4th?
Cactus.
X to the 4th cactus, okay. So it's kind of like this, right? And then negative x to the 4th, what does that do? Okay, it's going down. So what we're looking for here, we're looking at the end behavior of these particular graphs. Okay, this one right here, as I go to negative infinity, the y values are increasing. They're going up. Do you guys see how this is going up, 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 up? Okay, and then this way, as you go towards positive infinity, x is going down. It's decreasing. So here, we just have to look at our leading term that has the highest degree. We see that it's going to be like this. And so as x approaches here, where can I write this? Let's write it right here. So as x approaches negative infinity, meaning as it goes to the left, the y values are increasing. They're going up. Okay? And then as x approaches positive infinity, meaning as x goes to the right, it's also increasing. Okay? It's going up. So y is going in the positive direction. Make sense? Of course it does.